Okay, in this section, we're going to make the tires deflect, and I'm going to show you what I'm talking about right here. So I'm going to press play and watch the front tire. So as we take a corner, it deflects that way and that way. When you brake, it smushes down, it returns to the center. And this is a little exaggerated. The tire is probably a little bit flatter than it should be. But those are all settings you'll be able to adjust by in our subframe. We'll have some some custom properties, tire stiffness, how much you want it to deflect in the longitudinal direction when accelerating or braking, and in the lateral direction when cornering. We'll have a damping factor. So that's what we're going to work on. I think it adds a really cool effect, especially if you're doing like a rock crawler or some kind of off-road vehicle, or even doing like a flat tire. So let's get started. The first thing we want to do is we want to come to our subframe part, and we're going to add 4 new custom properties. So here I have them. Let's come to the first one, and we'll make it tire stiff. And we want this to be pretty high, so I'm just going to kind of put like 10 zeros or something. And our step size is going to be 100,000. And we'll put our default value at 500,000. Okay. The second one here, prop 1, we'll call the tire damp factor. And we'll just make that from 0 to 10. It's fine. This is just going to be a multiplier for how much damping we want. And we'll leave the step size at 1. I'm going to put the default value at 0.1. I think that works pretty well. And let's do the next one, which is the lateral factor. So tire lateral factor. We'll make this 0 to 100. We'll leave the step size at 1, and we'll leave the default value or starting value at 1. For the last one, let's do tire longitudinal or long factor. We'll put the max at 100. Leave the step size at 1, and I've had better results having this at 10 as a starting value. Okay, now let's make some adjustments to our wheel assembly just to make going forward easier. So what we want to do is I'm going to put my cursor at the wheel. So cursor selected. Or I'm sorry, I'm going to put the cursor here at the main sphere. Then I'm going to move my wheel to the cursor. So it's there. Now let's pick the upright, which is going to be in there. You might have to go in X-ray view, or you can just kind of click in the center a couple times. Let's move it along the X, get it out of the middle there, recenter everything. All right, now let's zero out the X value for the main alignment sphere here. So it moves everything back along the Y-axis. And let's move the cursor to the center of the wheel. So cursor to selected. And, oops, let's go into this view. Let's go ahead and make this upright a little smaller. I'm gonna tab into it and do S for scale and do 0.5. And I'm going to make it a little taller, so I'm going to do SZ 1.5. I've had problems with the upright getting in the way of things, and we don't want that to happen. So somewhere about this size. You can see the dimensions here. It's about 0.05 in the X and Y and 0.2 in the Z. Okay. And we also want to make the mass a little bit higher. It will improve the stability of the simulations I've found. So I'm going to make it 20 times. Now we want to add a lattice. So I have my cursor where I want it. So I'm going to do Shift A, then come down to lattice. Lattices are these kind of unique things, and they're always made at 1 meter cube dimensions. So you can see it here. And let's go to our new little properties panel for the lattice, and we want to up our resolution. So 3 in the U, we'll do 6 in the Y and 3 in the W, or Z direction. All right, now let's scale it. We want to scale it along the X, so it's about as wide as the wheel. I want to scale it along the Y, so it's about there. And in the Z, coming into a side view, let's scale along the Z, scale along the Z, and we want it about the thickness or the profile of the tire. So we don't have a tire yet, so we're just kind of estimating it. But somewhere around there. You don't have to have it perfect now, because when you apply it, when you merge it with a model, that's when you'll want to change this. But this is pretty good. So one of the things you should know with lattices is you should never apply the scale. Okay, your scale should always equal the dimension size. That's kind of important, otherwise it'll mess up how it does things, manipulates the meshes. So if you ever happen to accidentally scale it or apply the scale, so this is 111, the dimensions are going to be the scale you actually want. And these should be positive, and we shouldn't have any rotation in the lattice either. So if you have that, make this positive, make all these positive, and apply the rotation. Okay, so we have all that. We want to apply or parent it to the upright. So I'm going to Control P, parent it. All right, and we want to name it. So let's call it underscore tire lattice. Okay. Now we're going to have to change our constraint here for the axle. And to do that, I'm going to make a new constraint, basically. So I'm going to move some things around a little bit. I'm going to copy this axle, Shift D, Y, and we'll come to this one. And I'm going to copy the spring over to that axle. So I'm going to take this spring, select the axle, Shift S. Oops, I need to copy it first. Shift D, and then Shift S, or select the axle, Shift S, selection active. And I'm just going to make a new constraint geometry here. And it doesn't matter what this looks like. It's just supposed to be kind of intuitive. So I'm going to have this spring in the Z direction. I'm going to Shift D, press escape, and then RX 90. So now I have a spring in the Y direction. And I'm going to Shift D, escape, RZ 90. And now I have it in the X direction too. And that's what we want. We're going to have a spring constant in all directions. So that's kind of what we want. Now we want to join all this geometry. So I'm going to select all that, come up here, and say join. All right, I also want to apply the rotation if it isn't. Apply rotation. And now let's come over here and let's give it a name. This is going to be, we're going to call this axle deflect. Okay. And we're going to give it a generic spring. That is correct. We want it to be a generic spring. And let's give it some constraints here. So for angular, we don't want to constrain the X because it's still going to rotate about that. But we do want to constrain the Y and the Z at 0. For linear, we want to constrain all those. And we'll just leave those at default for right now. We're going to add drivers later, or here in just a little bit. We don't need to attach it to anything. And let's just delete this driver down here for the Z-axis, if yours has it. And we'll just make this 10 and 0.5. And we want that in all directions. So apply the spring constants in all directions for linear. Okay? All right. Now we want to move it over here. So let's grab it and we'll Shift D, copy it, bring it over close. We're going to delete this axle. Delete. And we're going to move this over there. So I have my cursor where I want it. So Shift S, selection to cursor. There we go. And we want to parent this to the upright. Control P. Okay, let's add the drivers to our new axle constraint. So let's come over here to the linear constraints, and we want to add a driver to the X. And the driver is going to be lat height divided by 10. And the lattice height, or the lat height, is going to be the lattice height. Let me go ahead and open this up in the drivers editor. Here we go. All right, so we want a single property, and we want to call it lat height. And we want to select our lattice. There we go. And we'll call it scale, or the property is going to be scale.z. I have tried using dimensions.z or dimensions2, which would be the z direction, and I've had some problems with some divide by 0 errors for some reason. I don't know why, but scale.z works. So I still have an error here, but I should be able to click in here and click out, and it should go away. And there we go. Okay, so that is that one. We'll close that out. And this should actually be negative, so make that negative. Then let's copy it down here. This one should not be negative. And then we want to copy it to the Y and the Z, and for both of them. So, but you want to take out the negative for the upper bounds. And for the Z, we don't want it divided by 10, we want it divided by 2. And we want to take out the negative for the upper bounds. Also, we want to connect this. I didn't do that. So the first object is going to be the upright. So here's our upright. And the second object, of course, is going to be the wheel, rigid body. Okay? Okay, let's do the Z-axis linear spring first. We'll add a driver to it. So add driver. I'm going to open this in the drivers editor so I have more room. And we're going to have a more complicated expression here. It is going to be tire stiffness. Actually, this one's not going to be complicated at all. Okay, and we'll do single property. We'll call it tire stiff. And we're going to pick the subframe, 2 underscores, and we want this to be tire stiff, like that. Okay, and we have that value, and we don't have any errors, so that's good. All right, let's copy this driver and put it into our damping section here. So let's open this in the driver's editor. Here it is. Move it over. Okay, and we want to multiply this by the damp factor. So damp, oops, I don't want to do that. I want to add another input variable. We're going to call that damp factor. And we want this to be the subframe again, double underscore subframe. And we want this to be tire damp factor, like that. All right, and we have that value and that value. If we click in here and click out, the error goes away, and we have our value there. All right, let's copy. We're going to copy our stiffness into, we'll just do the Y, paste the driver, and we need to edit this, and we'll do it in the driver's editor. Now we need another factor here. So we're going to multiply this by the tire long factor, tire longitudinal stiffness factor. And we'll add that variable, tire long factor. Pick our subframe again, and we'll target our tire long factor, like that. And that should be 10, so Click in here, no errors, we're good. And you can either copy it from here or the other place or down here. Either way, we're gonna have to add another one, another variable. So we want this times the damping factor 2, higher damp factor. So add another variable, higher damp factor. We're going to pick our subframe and target our higher damp factor. There we go. Shouldn't have any errors, no errors, and we're good. All right, let's copy this into X and this one into the X. And we're just going to have to change it to, instead of longitudinal factor, we need to be lateral factor. So I'm going to change it up here. Lateral. Lateral. And lateral. Okay. No errors, we're good. And we'll do the same thing here. Open in driver's editor. And we need to change this to lateral. Change this to lateral. And change this to lateral. Okay, there we go. No errors, and we're good. We have values for everything. Everything appears to be working. Let's save this. So we should have this constraint all finished for the wheel now.